This video is a part of the breakout sessions for the kickoff. This file and virtually any other file you will need will be accessible at the Best National Registry. So make sure that you have the proper account so that you can access that. Hello, my name is Mike King. I'll be presenting the introduction to EasyC. We're using version 6. If you're not on version 6, I would recommend that you get it. Thank you for watching.
These are just a few really top-level things that you will need on your computer in order to install and use EasyC. Obviously, Windows 7, 8, 10. RAM, disk space, obviously more is better. At least one USB port, because that's how you're going to connect to your controller. And you need administrative access in order to install it on your computer. The installation is fairly easy. All you really have to do is go to this link. It'll bring you right to the screen where it'll ask you to download it. This is where you have to run this to download, and you have to run it as administrator because it's going to try to, it needs to modify your system. Follow the instructions that you get, and you will have a key that will be provided to you to initiate the program. And after you install it, make sure you follow all the instructions. You can go to that website in order to see a lot more specific information.
EasyC is basically a visual programming environment where you drag functions from the function list and drop it into your work area. You don't have to write low-level lines of code. You'll drag a function from your list of functions, drop it into a work area. You'll get a pop-up, and it will request you to enter in some specific data to make that function do exactly what you want it to do. You can create a program to run a robot in a basic standard way with just a few steps, or you could create a very complex program that could run automated programs. It could do just about anything you want. There are many built-in functions. Function to take information from your joystick and control the motors, servos. You can get output from devices. You can send to sensors. And then at the end, once you've created your program, you will basically tell it to compile it and download it to the robot.
This is the controller that you will use with the Vex robots. I'm not going to go into any details. You've all seen controllers before. This is just to kind of give you a little orientation to the one that we will be dealing with. You'll see more of this later on. On this slide, I'm just trying to give you kind of an overview of the components of the system that you're going to be dealing with. The first thing, of course, is the joystick. This is what sends all the signals to the robot, the Cortex in this case, from the buttons, all the various things that an operator can do. All the signals will come from this, and it will be fed into the Cortex. And then you have devices that are also hooked to the Cortex. These devices, the obvious ones are the motors and the servos. You also have sensors that can be on here, so there's information going from the device to the Cortex, and the Cortex also sends information back to the device, certain ones of these devices. The Cortex, of course, is the brain, it's the computer. It's the thing that's controlling everything. And it has all the stuff that is built into the computer, the firmware, the operating system, the device drivers, which is basically just code that the manufacturers create that allows you to more easily connect to all these things, the joysticks and the devices, so you don't actually have to know the low-level way of communicating with them. And then there's the part of the Cortex which is set aside for user programs. This is where what you write will go here, and it will interact with the operating system, which will then interact with all those devices.
Here we have, basically, this is going to be a quick overview of what happens when you say build and download. Here's the source code. This is the stuff that you just wrote in your EasyC. It's a text file. You could look at it. It's human readable, but of course computers don't want to read it in that form. So enter the compiler. What the compiler is going to do is take that text C code and turn it into a binary file that the computer can then read. Then the linker, what it's going to do is take that binary file that the compiler just created, bring in a bunch of other binary files, potentially, that were loaded with the system. These are all the predefined functions that you use, and other things that it will need, like printing capabilities, whatever's built into the system. We'll take all those binary files, put them all together, and create an executable binary file. This is the thing that's actually going to run. It's self-contained, and then what you'll do there is you'll then download that executable binary file to the Cortex, and now your Cortex will have the software it needs to run whatever it was that you generated in your source code. Okay, we're now ready to bring up EasyC. So if you'll bring up the EasyC application, this is the screen that you should see when it comes up. If what you see is this screen, then you've selected the wrong Cortex when you installed your EasyC. What you'll want to do is go to your Tools menu, select Choose Controller. You'll get this pop-up, and when you get this pop-up, choose the Vex Cortex in the drop down and then select OK. Okay, so now we're going to start it. So what you're going to want to do is start a new project, and to do that you go over into your projects on the underneath the Start Page tab and select New Standalone Project. When you select your new standalone project, you should get this pop-up. You'll want to select a joystick project and then select OK. When you bring up a new project, the first thing that it's going to display is the controller configuration pop-up. Now you can dismiss this and go on without filling anything out here, and you can bring this up in the future anytime you want by simply going to Project Controller Configuration. If you have the information now, then you can go ahead and do it. And what you will use this for is under the motor type and description. It's just a text field. You can just type in if you know what you've designed your robot to be. You're going to have two wheels, a left and a right. You're going to have a motor for your winch, and you're going to have a servo, let's say, for your gripper. Then you can go ahead and type in the text here, and as you'll see later, when you are selecting a motor for a specific thing, it'll bring up a list, and rather than just saying 1 through 10, you'll actually see this text, and so it'll remind you which one you designed to use. Of course, you can select any one you want, but this one here this way you can match whatever it is originally decided you wanted to use. And again, you can come back in here at any time you want and update this text. So then you would select OK. Your display should now look like this. You have the standard file, the drop-down menu items at the top. The left box here, the way this window is configured to look, has all of the functions and the items that you're going to use when you're building your code, and we'll see more of this as we go on. The center section is where your code actually resides. This is where you'll drag your functions onto, and again, you'll see this more later on. As you notice, we skipped the right side that says the Project Explorer. That's a little bit more advanced, and we're not going to cover that in this video. Another thing you'll have is a bunch of icons at the top, and those icons basically are shortcuts to the drop-down menu I find it easier a lot of times to use those. There's a few of them that you're going to use regularly, and it's easier just to select it from that then, rather than traversing through the menus. The one you'll use a lot will be this symbol, which means build and download. So every time you change your software and you want to test it on your Cortex, you'll hit that and it'll build and download to your robot. And you'll see how to do that later. Another key one that you should be using is the save function, and I would recommend that you use that frequently so that you don't lose any of the work you've been doing. And this is the icon that you would select to bring up the controller configuration that you can do it anytime you want. So speaking of saving your program, I'd recommend you do it right now. That way you get the process down, and maybe it'll remind you to do it more frequently. So pick any name you want that's descriptive of this project and select OK. And then once you do this, from then on, when you bring up EasyC, it'll actually show you a list of your recent projects, and this one will be in the list. So from then on, all you'll have to do is double click on this project and it'll bring you right back up to your project. Now we start to actually do some programming. The first thing we're going to do is drag the while loop function over under program flow, under your function blocks. Drag that over to the line and drop it between the variables in the end box. If you accidentally drop it in the wrong place, don't worry about it. You can just select it and drag it and drop it into the correct place. When you drop the function onto the programming field here, a pop-up will come up. Now this will be the same for all the functions you drag over and drop. Some sort of a pop-up will come up. Each one will obviously be different because it'll require different data. But here you want to tell the while loop to basically run forever. So in a while loop, whatever goes in the brackets, it evaluates that, and if it evaluates to a 1, it continues. If it evaluates to a 0, it stops. So by putting a 1 in it, you're basically forcing this while loop to execute forever. So everything within this while loop will run forever. So it also has, and most of the pop-ups I think will also have a comment. This program that we're doing is fairly simple. It might not require them, but it's a good habit to get into, to put a comment in here. So later on, when you're looking down through your code, you can actually, just by looking at the comments, have a real clear understanding of what you're doing. So then hit the OK button. Your program should now look like this. You now have a while loop in here, and as you can see, there's nothing in the while loop. But let's talk about the while loop here for a second. When you put the while loop, if you didn't put the while loop in, the way this works is in the Cortex, it'll drop down and it'll run everything in this program. It would come down to variables, it would drop down on this line. If there was nothing here, it would just go right to the end and it would stop. So as soon as you turned your Cortex on, it would look like it did nothing because of course it would run once and stop. By putting this while loop in, what you've said is, when you're running, sit here and run between those two brackets basically forever. So this program would run until you shut the Cortex off. And so that's the entire reason for having this while loop in. So now everything you're going to do from now on, for this simple program we're going to do, everything's going to go within that while loop. This just leads us into the reasons why we're going to do the next function we're going to add. Obviously, most robots are going to need wheels. And we're going to be using something called arcade mode. And this is so that you can basically use a joystick in order to go forward and backward and left and right. And because the wheels need to turn in the same direction, even though the motors are pointed in different directions, that would mean that one motor technically has to move opposite the other wheel. Rather than having to worry about all that, we have a pre-designed function in our library called arcade function, which is going to take care of all of that, and it's just going to require you to put in a couple different pieces of data into a pop-up. So the way we're going to do this is the same as we did before, except this time in our function blocks, we're going to go down to the joystick folder, open that up and you'll see an entry in there called Arcade 2 Motor, which basically just means we're going to be in arcade mode and we're going to be using 2 motors. So we're going to drag that, and this time you're going to drag it over and drop it on the line in between the 2 brackets for the while loop, because we want to make sure this function is inside our while loop. And again, once you drop a function onto the workspace, a pop-up will come up. In this case, it's the information that's going to need in order to configure the arcade function. The thing you have to, anytime it asks for a joystick number, you always put in a 1, because in BEST we only use 1 joystick. That's probably the default, so you probably won't have to change that, but that is going to be a 1. The next thing you're going to have to do is decide which joystick channels you want to use in order to control the movement of the robot. Typically, you'll use one of the joysticks. In this example, we're using the right joystick. You could just as easily use the left one and use the different numbers on it and it would all work fine. But in this case, we're going to put in a 2 for the forward reverse, because that's the one that moves that joystick forward and backward, and we're going to use a 1 for the rotate channel, because that's going to be left and right, moving the button left and right, so it'll move the robot left and right. The next thing we're going to have to do is pick, okay, what ports are your motors attached to? And this should match what you designed earlier and put in that configuration pop-up. And so when you hit the drop down for the left motor, you'll see something that will say left wheel, so you'll just pick that, and it happens to be the description for motor port 9. Same thing on the right motor port, you would hit the drop down. If you've put in the text in that configuration pop-up earlier, it'll say right wheel. You can select that one, and that'll be equated to the motor port 2. Now these motor ports, you can see in the picture on the bottom right, equate to those slots in the Cortex. The motor direction, typically you won't have to do anything here. If for some reason one of the motors was wired improperly or something and it was running opposite from what it should, you can actually fix that problem by coming in here and switching the 0 to a 1, which will then invert the direction that it moves. I don't really foresee you having to do it, but this is one place where you could go in and fix that spin direction so that it's the correct direction. And this box here shows you what the code is going to look like when it puts it into the code on the main programming spot. And again, make sure you add a comment. Again, this is a simple program. It isn't necessarily all that important, but it's nice to get in the habit of putting in a comment in these things. And then you just select OK. This is now what your code should look like. As you can see, the Arcade 2 function is now in the while loop, so that's good. If for some reason you notice that arcade mode was not inside the while loop, you'd want to drag that and put it inside, or else it'll execute once and never again, and it'll look like nothing's happening. Now at this point, if you did a build and download, you could actually run your robot around with nothing else. Just this one line of code will give you the ability to maneuver your robot around. So a robot is now able to be moved around, but it can't really do anything. So the thing we're going to do now is we're going to add a winch that will be able to raise and lower the arm. And we're going to use a single motor to do this. But this time, rather than using the joystick, we'll simply use a button to control the winch. So again, we go over to our function blocks, still under joystick, and we are going to drag the function joystick digital to motor over to the while loop and place it just beneath the Arcade 2 function. The function we picked this time is different than the previous one, so therefore the pop-up, of course, is different. As you can see, I skipped joystick simply because that's always a 1. If you do happen to notice it's not a 1, make it a 1, but the default is 1. So this time we're going to pick channel 5, and as you can tell, we call it a channel. Some people will refer to it as a button. That's not exactly correct, but we use it. We kind of know what we're talking about. But it's really a channel because, as you can see here, there are 2 buttons associated with channel 5, and you have to tell it what to do with either one of those 2 buttons being pushed. And we're using 5 for this particular one. So, as you can see, the button number 1 equates to, says down. If you look really closely, you'll see a U and a D on those 2 different buttons. There's an up button and a down button. The first button we're going to configure is number 1, which is the down button. And for this one, we're going to tell the motor to move at a rate of 50. Since the range of values that you can put in here is -127 to 127, what that's saying is it's going to be moving in the plus direction about a little bit more than a third of the speed with which that motor can go. And this is something you can play with. Once you get it all going and you realize, oh, it's either going too slow or too fast, you can simply double click on that function and change this number to whatever you need it to be. Sometimes you have to play with it a little bit to get the exact right number. Then the next button we're going to configure is number 2, which is the up button. And since we were moving in the plus direction for button number 1, we're going to make this one move in the negative direction. So it'll basically move the motor the opposite way of the top one. And we're going to have it move at the same rate. So basically what you're saying is I'm going to push those 2 buttons, and if I want to go up, I'll push one button. If I want the winch to come down, I'll push the other button, and they'll go at the same speed. Now sometimes you might want it to go up faster or whatever. Again, you can come in and play with these numbers however you want to. And again, we have to pick which motor port this is going to go in. We've already used 2 and 9 for the wheels, so we're going to pick another number. It doesn't really matter what the number is as long as it's an unused one. And so we've decided to pick 4 for the motor port. And again, comments, I would recommend get in the habit of doing this. It's not that big of a deal, and it's a good habit to be in. And then select OK. And now you have 2 lines of code in your program. So at this point, if you did a build and download, you'd be able to move the robot around, and you would be able to move your winch motor. So now you have the ability to move your robot around. You can raise and lower the arm, but you can't grip anything yet. So what we need to do is we need to add another line here that allows us to open and close some sort of a gripper. And to do that, we're going to use a servo. And to use the servo, we're going to go down again to our function blocks under the joystick category, and we're going to drag the joystick digital to servo function over and place it just underneath the joystick digital to motor function. So here's the pop-up for a joystick digital to servo function. And like the previous one, you're going to select a channel. This time is channel 6. And this one looks remarkably like the other one because channel 6 has the same number of buttons as channel 5, therefore it has 2 options. In this case, you're going to have again an up and a down button. For the down button, you're going to put in a value of 127. Now for a servo, this is not a speed at which the thing is turning. This is going to be how far open or one direction it's going to move. So servo has a center position when it's at rest at the 0 mark, and then you can go plus 127 or minus 127. So in this case, we're going to go plus 127, which says go as far to the right or open as you can go. Now, again, once you put this into place and you decide, I don't know if this is exactly how far I want this thing to open, you can come back in here and you can play with this number until you get it to move exactly how much you want. And then you do the same thing with the other button, except this time it'll open the servo in the opposite direction, and again it's going to open it to its max capability. And you could come in and play with this number also, and these numbers do not have to be the same. And you're going to, again, you have to pick a motor port, so just pick one that you haven't used before. And one good rule of thumb is you have basically ports 2, 3, 4, 5, and 6, and 7, 8, 9, and you have like 8 ports you can use. Try to spread them out amongst the first 4 and the second 4. It's kind of a power management thing. I'm not going to go into the details of that, but if you can, especially with the bigger items like the motors, keep them on different sets of 4 just for a power management kind of a thing. So in this case we're picking port 8. And again, comments, just get used to putting comments in. I think it's a good practice. And then hit OK. So now you have completed all the software you need to run a simple robot. This code will allow you to move the robot around in arcade mode. It will allow you to raise and lower an arm, and it will allow you to open and close a servo. Now, if you decide you need, in your gripper, you want to have 2 servos, or if you want to add another motor to it, you would effectively add either a second servo or a second motor, and you would do it exactly the same way as we did the previous ones. Again, you'd have to pick a port that's open and pick some buttons that haven't been used yet, but it's the exact same process to add more of those in here. Now that we've finished the software for our robot, we need to download it to the Cortex. And there are two ways you can do this. You can connect directly to the Cortex, or you can connect to your joystick controller, which then through Wi-Fi connects to the Cortex. And we'll discuss these in a second. The first method I'm going to talk about is connecting to your controller. This is the method that I prefer, but you are free to use this one or the following one. The way you connect it is you have 2 cords in your kit. One will be a USB at one end with a standard kind of a phone plug at the other end, and that's what's shown in this picture. And the other one is simply going to be a USB to USB, which you'll see in the next slide. So here you attach your computer to your joystick in this manner. Make sure that you plug into the program port, or else it won't work properly. The pros for this are basically you have the ability to debug in real time, meaning while you're running your robot, information is coming back from your robot to your computer, and so there are methods for being able to display that information. Of course, I'm not going through that here, but it is a possibility. You can run without being tethered, and you don't have to remove and insert keys in order to do this. And as soon as you build and download, you can pick up your joystick and start running your robot. You don't have to do any fiddling with it. Now, of course, the download is a little slower because it's Wi-Fi as opposed to direct connect, but the size of the programs that we are typically doing here don't make that a really huge deal, but of course you can decide for yourself. And in this particular configuration, you need to have the battery connected to your Cortex in order to run. The second method is a direct connect to the Cortex. As you can see, here is where you'd use your USB to USB. You do have to remove the key from your controller, the Cortex, but you don't need it to be hooked to a battery because USB is powering it. The pros, or the biggest one, of course, is that the download is faster. You don't need the battery connected to your Cortex. The primary con is that you will have to be tethered to your robot if you want to run it directly after you download this. And there's no advanced debugging because there's no information coming back to the computer from the Cortex. So now that you've hooked your computer to the robot, whichever method you choose, now you have to initiate the build and download. There are two ways of doing this. One way, you can select the menu item, build and download, and go through it that way. Or you can hit the icon. I prefer to use the second row with the icons because it's a one button push for all of these things, and the function occurs. You don't have to traverse menus, but you can certainly do it either way that you feel comfortable with. So select build and download. When you hit the build and download, it will start running, and down in this window here, the output and task, you'll see it, lines will be appearing here. This is the build process occurring. If there's an error in the build, it will occur here, and then of course you have to look at the specific error to try to figure out what exactly it is that went wrong. Once it finishes, you'll get this pop-up, and it'll say that the file was built properly. This is the execution file that I talked about earlier. And do you want to download this to your Cortex? You don't have to download it, but typically when you're building it, that's what you're going to want to do. So if you want to download it, you select yes on this pop-up. Once you start downloading, then you'll get this progress bar, which will creep from left to right. And once it's all the way to the right, it'll finish. You'll get information here under the robot. If it doesn't work, if it can't connect, one of the big reasons is you've forgotten to connect the battery to the Cortex. If you're doing it connecting to the controller, sometimes the batteries are low. Sometimes you forgot to plug it in to the computer. So this right here will give you some clues as to what may be the problem if it isn't downloading properly. So when it's successfully downloaded, you'll get this pop-up. All you have to do is hit OK, and then you're done. And at this point, you have a program onto the Cortex, and you can now test it to see how it works. And when you run into problems, you can go back to the beginning and update your file and go through the process again. This is just here to show some of the really common errors that occur, especially the first few times you run it. One of the big ones is you forgot to put the function inside the while loop. Another one is the motor port that you have the wire plugged into doesn't match the motor port that you selected in the function. So those are pretty easy to check. Another one is that you selected the wrong joystick port, so you thought you had selected, one of them, and you really selected another one. And of course, this sounds kind of silly, but a lot of times what happens is you wrote your software and you saved it all okay, and you just forgot to do a build and download. So if when you try to run, it seems to be running the same way as it did before, sometimes you just forgot to build it and download it. The following charts are just a little bit of additional material that will kind of give you an idea of a few slightly more advanced things that you could do. Not a lot of detail is going to be going into, but it will at least give you an idea of the things that you could maybe look for and start researching on your own. Thanks for watching this video. This is just a reminder that the National Registry is where you can find all these videos, a bunch of other files that teams need to be working with, and also a reminder that you need to be able to log into the registry. So make sure that you all have access.